Hello everyone, it's August the 3rd. Alright, let's get right into it. What do we have? Subsets 2. Given an integer array, nums that may contain duplicates, return all possible subsets. The power set. Have I done this before? The solution set must not contain duplicate subsets. Return the solution in any order. Given an integer that may contain duplicates, return all possible subset. So empty 1, 1, 2, 1, 2, 2, 2. Okay. Numbers is to 10. Subsets with duplicate. Okay, so we're given 1, 2, 2. We want to find all the subsets. All the subset. And the subset, the solution must not contain duplicate subsets. Return the solution in any order. So the empty set is a subset of any array, right? So we say if we take 1, right, then we have the remaining. We can say everybody by itself can be a subset, right? And then so the remaining, the 1 and the remaining. So if we have all the non-duplicate subset of the remaining, if we can find it, then we can add that to 1. So now the question is, what subset can we have for 2, 2? Now for 2, 2, we can say if we take 2 out, right, and we have the remaining, and we know what we have for the remaining. Now the remaining is a 2, so that one can only produce a 2, right? So we have 2, and we have a 2, 2. That's the subset a 2, 2 can produce. And then and every time they're produced by themselves, we add it as well, because those are subsets as well. So we don't have to keep going. Yeah, it's like the subsets that include 1, everything that includes 1, and then we got everything includes 2, and everything includes this, and those themselves are the subsets as well. So when we find them, we can add them as well, and then we return. Right, so we have 1, get a 1, 2, and a 1, 2, 2, right? And then that's it. So 1, 1, 2, 1, 2, 2, 2, and 2, 2. Okay. We didn't encounter any duplicate situation because the recursion, we did not return an empty set in the recursion. I think that's why we did not. If we return an empty set, yeah, then we'll have duplicate. So we do not return empty set. We only return empty set in the final result. Okay, let's go through the logic again. So what we're doing here is we're just gonna go the subset include the first value, right? Will be the first value, or all the power set, all the subsets of the remaining, and then we add it to the first one, right? So that's everything that includes 1. Now we know everything includes 2, right? But we already computed it, right? Because that, when we take this out, with the remaining, we already computed. So it basically means whatever we compute, we need to put in the result. Let's give this a shot. It might be right, but I'm not 100% sure. So do this. Okay. Another one is there's only 10. All right. If there's only 10, I think it's possible to do a combination. It might pass if we just do combination and then we do combination. But how would you, if we do combination, how do you avoid duplicates? We can. Yeah, we can. Because there's only 10. You know what? I actually want to try this combination. Things from iter-tools, import, right? Combinations. Basically, oh, that will be the full combination. Like 1, 2, 3, all the way to that. And every time the value comes out, we need to turn it into a tuple, because tuple is hashable, right? So we're going to sort it, turn it into a tuple. So what I'm saying is we can do, the result is this, right? I'm going to say for length, for size in range, okay, 1 to len num, plus 1. Now we just do len nums, doesn't matter. So the result will be empty and nums, right? So that's the result. And for each one, we're going to say combinations, nums, and I think size is size, right? For combinations this, then what? We're going to turn into a set, right? Turn into a set, and for each one, for each com, for C in combination, right? We're going to turn C, we're going to sort it C. After sorted C, turn C into a tuple, right? And turn C into a tuple, we're putting a set, right? After we've done that, it's removing all the duplicates. After we've done that, we turn it back into a list. After we do that, we say res plus equal to this, and we return res. I'm not sure. It's look very convoluted, but yeah. Maybe this one will already work. I mean, if they'll go, I mean, we definitely will write another solution, but I feel like this one shall work, given that we have only 10, so it's a very small test case, right? Very, very small. So if it's small, I think we have a chance. So here is going to be subset with duplicates, nums, it's actually nums, right? Nums, and when sort again, sorted res equals sorted answer. Ooh. Okay, we cannot turn it into a list because, okay, so this is a set, right? So to turn the set into a list, but we're going to say for S in this, right? For S in this, we're going to turn S into a list. Yep. All right, this might pass. Honestly, this might pass. It's because we only have 10. The length is 10. Yeah, this pass. So this is a cheating method. We basically use combinations to get all combinations from nums. Then use set to sieve out the duplicates, and turn, and then and then add the non-duplicate combinations to the result. I don't know the runtime for this. This one will run, which not too bad, in 40 milliseconds. 1% rank. All right, so this is just for fun, right? It's just for fun. We're not gonna do this. We're gonna do it the real way. I mean, runtime O n square. Oh no, combinations. Oof. Combination could be more. Anyway, let's try solution 2, which is what we're thinking about, right? So what are we thinking about? So result equals this, right? It's a def helper. What we need is index, which is the starting value, int, and we're going to return a list of int, right? So if index, so we let's call n equals len nums, all right? So index equals n minus 1, that's the last value. We simply return, have to be a list of nums index, right? Because that can only give us 1. Otherwise, we take, we not only do that, but we also, but hold on, you still have the duplicate issue we haven't resolved. Yeah, now I see where the duplicate can happen. 1, 2, 2. So the last 2 comes out. We cannot get inside res. Well, I mean, Let me think. Let me think. Minus 10 to 10. Maybe there's a easier way to identify. Yeah, it is. We do have an easier way. It's minus 10 to 10. Minus 10 to 10. That's 20. That's 21 actually, for minus 10 to 10. So we can easily, in this case, we can easily replace each number with a letter, right? Replace each number with a letter, and when we do this, we basically turn that into a string, all right? Into a string. If we turn that into a string, then we say each combination is going to be a string, right? A combination of a string. Then we can use a string to avoid duplicates. That might actually work. All right. So from minus 10 to 10, we can map minus 10 to 97, which is lowercase a, and the 10 is we just do everything, the number plus 10, right? The number plus 10 will be the 1. Yeah, the number plus 10, whatever number we have with plus 10, then we get and we have it. Then the nums and the rest is going to be a set, right? So n is this, and then we say nums str equals, we can do join. It doesn't matter. We'll just do this. For I in nums, I don't want to say for n in nums, but then this one has to be n, right? For n in nums, we're going to do n plus 10, right, plus 97, and then we're going to do char this, right? So that's the num_str, right? So this is not going to return a list of lists. This one just going to be returning a list of, well, it's not a list. It's not going to be a list anymore. It's going to just return a set, right? A set of str. I think it shall work. A set of str, right? So this one is just going to be a set. The result is a set. So if this equals, which is the last one, then we're going to return, we're going to say, what do we return? I'm going to return a set, right? So I'm going to return a set which contains, and set we can do plus. Oh, hold on. A set we cannot do plus. Hold a sec. So the result is a set, and every combination becomes a string, all right? Every combination is a string. And we need to sort it first. Let me think. I mean, what's the difference between this and then you turn that into a tuple, right? You can just turn it into a tuple. But we can't just turn it into a tuple. That's basically, it will be the same as this, but we're just writing the combination ourselves. Huh. Interesting. Yeah, we return a tuple, and yeah, result becomes a set. You know what? Yeah, let's just do tuple. So what we're going to return is going to be a list of tuple, right? A list of tuple. So if this, we're just going to return a tuple. It's going to do this and nums index, right? That's a tuple of one value. That's what we return. But then we need to say res.add nums index. This, right? This is to add it to the nums. And then for index not this, we first get remain. Remain equals helper index plus 1, right? After we do index plus 1, then we can build bottom up, right? We just build this, we get this, and then we go here, we get 2. Yeah, we get this, and I will go to the next one. We combine these together, add it, and then we do the 2. Now it will be easier to do recursion. So remain is this, right? And then what we do is we get everything from the remain out. Can we like append tuples? How do we append tuples? It's a good question. I actually don't know. Let's see. A is, let's say, a tuple 1, 2. B is a tuple, let's say 3. A, B, A plus B. Oh, I can do plus. Okay. Oh, yeah, we need to sort it in order to do this, which will be easier to do if we sort here, right? So let's sort here. Nums.sort. All right. Once we sort it, then once we sort it, maybe the question will be easier. If we sort it, then the duplicates will be all jammed together. Right? because if we have multiple duplicates, if I have n duplicate, right, I have a value duplicate n times, then the number of possible subsets in this is just 1, 2, 3, 4, like n. We have n subsets, all right? That's an interesting thought. That is an interesting thought. So what we're thinking is, how about we do a counter, right? We counter. So we have the key. So each value is unique, but we know how many repeats we have. And then we do a unique, well, we do it uniquely, right? So we have the combination of uniques. Then we get uniques, and afterwards we iterate through all the unique solutions and pick out everything that has duplicates. So everything has duplicates, we'll be able to expand, right? Let's say here, right, the uniques will be 1 and 2. So the result is empty, 1, 2, and 1, 2. So that's the uniques. But 2 has duplicate 2 times, right? And we remove the 1 with 1 element. So with 2 elements, it's 2, 2, right? So everything that contains 2 will be expanded to 2, 2. Everything contains 2 will be expanded to 2, 2. So this essentially means we can use combinations. Let's use combinations. So first of all, we need to say counter, right? Counter equals counter nums. So we're gonna do counter. Collections import counter, right? So after counter, we're gonna say res equals, I'm gonna say for key in counter dot keys, right? No. That's going to be combinations, counter dot keys, and size. For size in len counter. Actually, for size in range 1 to len counter plus 1, right? That's all of it. And then we have, each one we have a combination, right? And a combination coming out. Wait, when we do combinations, what do we get? That's probably listed, right? So it's going to be this. So for the sizing range, in this range, for each one we do combinations, right? And then when we do combinations, we're going to list it. After we get the combinations, we list it, right? We can actually return res. Just take a look how it looks like. If it's solution 2. All right, so we have, each one is a tuple. Oh, that's not right. That's not right, because it's 1. We list it, we have the list inside as well. And then we also need to deconstruct it. Oh my god. That is not how I want it. You know what? I might as well just write it yourself. Right, let's just completely write it ourselves, which is fine. This is fine. So we're gonna say keys equals list counter. Actually, we probably can just do counter dot keys. Oh, I'm not sure. Counter dot keys, I don't think we can. Let's just list it. All right? And then let's write it ourselves. Res is this. Def comp, right? Comp, I'm gonna have an index, int, and return a list of list int. If index equals len keys -1, right? That means it's the last index. Then res.append keys index, right? And then return 2 levels keys index, right? Otherwise, we have index remains equals com index +1, right? Now, after that, we're just going to iterate through the remains, and we're gonna on the return, it's going to be me myself and the rest. Let's see. Yeah, so we iterate through the remains, add my current value to it, then we get a temp, right? And then we return the temp, and I think I get temp here. So temp going to be equal to index keys index, right? So that's a temp, and rest plus equal to temp dot extend temp, and we return temp. We're going to return temp anyway, so we'll just do this, else, blah, blah, blah. Finally, going to return temp, right? So remains equal to this, and we're going to say for r in remains, right? For r in remains, we're going to do temp dot append, right? Temp dot append temp 0, which is the current key, plus r, right? And when we're done, and then this one, I'm pretty sure we can just put it here, right? So for this, temp dot blah blah blah, and after we're done, we're gonna return. No, we also have to say res dot extend temp. So basically, we can say if this is smaller, right? We can say if this is smaller than this, don't do this, don't do this, we do this, and after we're done with this, we're gonna res.extend, right? And extend the temp, that's to save the current result, and then return temp for the next value, the next level. So when we're done, we call it combination 0. That's the first one, right? And after we call this, we can return rest. Let's see what we have, if it's as expected. Not really. We have index out of range. Huh. Why would we have index out of range? We say keys if key. Oh, because we, okay, I see. So we do have to establish, so temp equals this, right? If index is smaller than len key, -1. Okay, now we see we have 1, 2, and a 1, 2. That's exactly what we want. And after we do the combination, right, now we have the rest, then we are going to iterate through the result. Oh man, we're going to iterate through the result. We iterate through the result, and based on, wow, this is we're trying to expand it. Yeah, I don't think this is easy to do if you want to expand it this way. Right? We're given each one, and I mean, technically speaking, we can make these into sets. So what we can do is we know which ones. I don't think this is. We iterate through these, right? And then, man, no. I think this is more convoluted than it's supposed to be. We did a combination, right? We did a combination, and then I was saying, because we might have multiple keys that they have multiple things here. Actually, if we find, right, let's say we go through these and we find all of them, and then what? And then they can, yeah, we're gonna list them out, right? We list them out, or let's say like when we find one, right, and we just list them out, and they need to do product, right? So like the Cartesian product of all of them. Does Python's product do Cartesian product for more than 2? I think it's in the tools. Import product, right? So product. Yeah, I think I can do 1, 2. Let's say 1, 2, 3, 4. Right? Let's also say 5, 6. Oh, yeah, it's listed. Yep, I think it's all of them. 2 times 2 times, which would be 8. 1, 2, 3, 4, 5, 6, 7, 8. So we can use product. If we use product, that means for each one we have repeats. Going to get a full list of the repeats. And then we're gonna product them. And then after we product them, we get the remaining. Man, that just seems so, how should I put it? So convoluted. But I guess it will work. So we have to use product. I don't know. This is getting down into a rabbit hole, right? What do? We just say for so R in res, right? R in res, each one, and for every value in it, we see if we have. Oh man. Hmm. So we don't do counter. We do repeats, right? Let's see. Repeats equals this, right? And then we say for n in nums, if n not in repeats n equals n. Else, repeats n equals. Now we can use default dict then. Default dict with a list. Yeah, I already lost sight of what we're trying to do. We use default dict, and we don't use counters, but we use when we use product. Man, this is just unbelievable. If it's not in repeats, actually I don't need to use default dict. Yeah, let's just use, I don't need to use default dict. So just this one equals this, else repeats. Ooh, that's actually going to be this, right? Else repeats n dot append repeats n -1, right? Plus n. So we do this, and keys and then equal to repeats.keys, right? Repeats.keys, rest equals this. We run the same thing, but then we say for r in res, right? And we're gonna get all possible repeats. Temp equals this. My gosh, this is just so convoluted. That's definitely not the way to go for R in res, for n in R, right? For n in R, if len repeats n is larger than 1, right? Temp.append what? Repeats n 1 to the end, right? We want to take two or more. So after we do this, then what? We can do product, right? Then we do product. We say for p in product, then we need to deconstruct temp, right? And for each one product, actually I'm not sure. So what we're saying is what we're saying, right? So 2, 2, 2 and 2, right? Let's say 3, 3, 3, 3, 3. Yeah, I think that's what we're saying. What this one gonna be? Man, we need to flatten it. So the product need to flatten, right? Man, we need to flatten P. How do we flatten? Do we have flatten? Data tools, flatten. Even if we flatten, it's probably not going to work. You know what? I don't like this. I don't like this at all. It's convoluted. It's terrible. Yeah, it's truly terrible. No, this idea is not going to work. So what? We go back to, but if we go back, it's going to be this. We do tuple, we sort it, and there's no difference compared to this. So basically we're saying we're going to try to write this thing, but not using combinations. We're using all the other tools. Okay. Yeah, let's do that. Let's do that. Yeah, I don't like where this is going. This is going weird. Okay, so res is going to be wait, how do we check? Well, we check inside. So res is going to be a set, right? Res is going to be a set, and every time we push to the res, we're going to push to a sorted Yeah, I want to push a sorted tuple, right? Sorted tuple, so the rest can avoid um, avoid duplication, which means this is going to return a list of tuples, right? Yeah, this is going to return a list of tuples, and we'll get the tuple out. We're going to add a new one to it. Can we sort tuples? I think we can. Sorted, let's see, 4, 1. When you sort it turns into a list. Well, we don't have to sort if num is sorted. If num is sorted, then we don't have to sort. Okay? So this one, I think we need to return a tuple. A list of tuple, right? So temp is going to be a tuple. Right, that's what temp is. Temp is going to be a tuple. And we say if it's smaller than this, and anyway, at the end, we're going to say for t in temp, right? Rest.add t. We add a tuple into it, and then that helps us to avoid duplication. And in here, when the combination, the rest for each r is a tuple for each. Let's not call it r. Let's call it tup, right? So we know it's a tuple. So if each tuple comes out, we're gonna do temp dot append. This is actually, don't know. We're trying to talk about. So 1, can we destruct a tuple inside? Oh, yes, we can. Oh, okay. So we're going to append temp 0, and we are going to destruct a tuple. Right, that's what we're going to append into the temp. And afterwards, we're going to add everything. Now return temp. Okay. So once this is done, we're going to call comp 0. Right? Take a look. Tuple is not defined, because I didn't say a tuple here. Keys is not defined. That's not key, that's nums. Another keys. It's going to be nums. Smaller cannot be used. Wait, where? Oh, it's sorted and sorted. Because it's tuple. Wait, what do we have? Let's print rest. I don't know what we have on the rest. Alright, rest is a weird combination of things. Oof, what the hell? That is not what I expected. But it is a result. 2, 2, 1, 2, 2, 1, 1, 2, 2. Yeah. So what happened? I return a tuple in the list, right? And then I should get every tuple out, and I deconstruct tuple. Right, this is where I deconstruct the tuple, and I put it into a new tuple with temp 0. Nah, that's not temp 0. That's not temp 0. That's nums index. There we go. That's that. So now, after we're done, we're just gonna return, right? We're gonna return. We have to turn everything into a list. So we say list r for r in res. And to 2, almost. So what we need is an empty, so return this plus this. There we go. All right, let's try this. So we, come on, get the internet back. All right, I get the internet back. Oh, I haven't tried this one yet. All right, both pass. Try this. Oh, I got wrong answer on this one. Let's see what we have. We're missing 1, 3. How? Very interesting. The result is this, but we're missing it. You know what? I think the actual solution will not use tuple to do all these fancy stuff. Okay, so what we have 1. We have 1, 2, 3, right? That's what the result. We have 1, 2, 3. We have 1, 2, 2, 3. Well, 1, 2, 3. We don't have 1, 3. We're missing 1, 3. Ah, I see. We are missing 1, 3. Why were we missing 1, 3? With 1 taken out, 2 out, so 3, right? And then 2 and 3 we combine together. That's 2, 3. And 2, 3 returns. That's why. Okay. Okay, so we need to call this. We need to call this, and then for top in res, then we append. Right? Then we don't have to return anything. This will not return anything. This will return none. So temp is this. Why do we need temp? Well, we don't need temp anymore. Right? So I think we just say if index equals len nums minus 1, we just say res.add a tuple nums index, right? Otherwise, we're gonna first do this, which give us all the combinations, the remaining, then they stored in res. And then for each top in res.add this thing, right? Res.add this thing. We don't have to do anything here. Oh, I forgot to return. So this one has to return. Set size changed during iteration. It does change. Okay, so we can copy it. Or we can have a temp equals an empty set, right? And we'll just say temp, I'll add, and at the end, we say rest.union temp. Wait, does union return a new one or not return a new one? Good question. So I say A equals set, B equals set, A dot union B. Oh, I return a new thing. And A and B doesn't change. So we have to say res equals this. Okay. Res is defined in close reference. We cannot do this. Ooh. Okay, we can just interesting. So let's just return them. Yeah, we're gonna return a set. Let's just return a set of tuple, right? And then if it's equal to this, let's just return a set of this tuple, right? And then we're going to call this the remains equals this, and temp going to be a set, and everything in the remains I'm going to put it into it. So with this, for this, so temp equal to a set of this. Alright, and then we're going to return remains dot union, and it's going to be for this in comp 0. I'll call it top. I'll call this one top as well. Okay. Not correct. 1, 2, 3, have 3, 1, 3, and 2, 3. We're missing. Why are we missing? Because the last one is 3, right? And then remains, this one gives us 3. And then the 3 comes out. Oh, that's the new one. All right, that's the new one including 2. So I have 2, 3. And remains is 3, union 2, 3. So it'll be 3 and 2, 3, right? And then comes the first one, 3 and 2, 3. So it should be 3. Should be 1, 3, And then, wait, are we missing this 1? 1, 3, 2, 3, 1, 2. We're also missing 1, 2. We're missing a few. We're missing a few. So temp equals this, right? And then temp dot also add. We need to add nums itself, nums index. Yeah, add this. Temp equals this, and then we can save a line. That's the remaining. And then add this, return this. Remains is not defined. My God. We do need remains. Shoot. Yeah, we do need remains. And we just need to add another one. And then we're going to union these two. So we don't need this. We do need sort. That's we need to sort. Okay. I'll try these two. All right. Try this one again. Submit. Yep. So I accept, but it's so ugly. So ugly. That's gonna probably slow. Not ready yet. So anyway, so this one, it's basically the same idea. It's the same idea, right? The same idea as solution 1, but we are writing the combination part by hand. That's it. That's the only difference. All right, let's go to. Oh, I just clicked the wrong thing. Don't want to subscribe. I just want to see what is the smart solution for this one. Okay. Number 90. Maybe I've done it. Maybe I've not. 90. Yeah, I've done it in the past. That's 2019, right? September. Not September, oh, it's July. 2019 July, more than 2 years ago. This one gives us 40. That's all 40 milliseconds. There's also 40 milliseconds. Okay, what type of method did I use in the past? All right, this is what I use today. That's what I use today. Oh, I was clicking this. Of course, I just clicked the one I used today. I do counter. Oh, it does work. Counter does work. Get a size for each one. Oh, this is a good solution. Oh yeah, it is using counter. Oh, and we can iterate through k and value, right? Size. Wait, size equals len size. For I in size, for n in range, 1 to v plus 1. Res I. So for each one, hold on. What are we doing here? So the rest is just a list, right? And then we do the count. So we have a count, I have a key value, we have a count. That is the idea that I had earlier. And then let's iterate through everything we have so far. Okay, that's fine. We iterate through everything we have so far. And so we iterate through everything, right? And then we add that at what we have. Res I is what we have, and this is the new thing comes in. We say everything in the res has to append to the new thing that's going to be added in. And the new thing, depending on how many times we need, yes. Oh, now I remember. That's how you do combinations for this. Like, it's not combination, it's combinations of all different sizes. You just go through the rest, right? Go through the rest. That's everything of the previous size. And then you add 1, which is the current new value. Everybody will add a current new value. And then go through every one of them. Okay. Yep. Yeah, so we say everything that's already been done, and then the new one coming in, everyone has to add the new one. And I have to add the new one, that's all the combinations of the previous. Yes, that is the solution. How did I come up with this? I must have checked the solution. Well, anyway, let's do the smarter way. So this must be the smart way. I had this solution almost more than 2 years ago. More than 2 years ago. And I think this is also the standard method to obtain combinations, right, of an array. of all sizes, right? Which means res equal to this. Oh, we do need counter. Yeah, counter equals counter nums. So res is gonna be this, and for kv in counter dot items, right? We just say for I in range len res, because we need to iterate through everything. So I in range this, and for each one, I need to add the current. And that is based on how many v I have, right? So we iterate through everything in the res, right? We iterate through everything in the res. When it comes out, I am going to add the current thing to it. So I'm before j in range 1 to v plus 1. Right, that's the number of repeats we have. So for every one, we're going to do n times j, right? And res I, that's everything we have. Now n times j is the current one we need to add. So we add it, and the res dot append this. And we return res. N is not defined. That's not n, that's k. Yep, so that is the smart solution. Oh, it's faster. 36 milliseconds. What's the runtime on this? Well, here's on. So on, and we build this up. This is gonna be this is on squared. This line is on squared because the rest is growing, right? This is gonna be on not squared. How many in total? In total is 2 to the n. This is a 2 to the n. This line is 2 to the n. And this is going to be, doesn't matter, sometimes 1, sometimes 2. Most will be on. For every value of it 1, but this one dominates. Right, this one dominates. So this is a 2 to the n. Yeah. Bit masking. That's probably bit masking. One line with product. Oh, is it chain? Yeah, I think it's chain. Chain is to flatten. No, you have to first, you have to first deconstruct and then chain it. Yeah, the whole thing is flattened. So counter, right? So arrange this, and we're going to do product. 0 to v plus 1, right? And then we do k times I. Okay, that's the repeats from 0 to everything. Turn that into a list. Destruct it. And this is to here, right? That's everything. I have that in my mental image. Destruct it, product it, and for each one, so product it, it's just going to be, the product together. Yeah, we're treating each repeats as an individual value, and we do I, and oh wow, that's great. Yeah, very good. Very, very good. But aren't we gonna have a lot oh, it's required, the empty set. I think the empty set is required. Is it required? Empty set? Yeah, this, and this. We want to take elements from this, and we use okay, each element. What does chain do? Forgot. What does chain do? Probably should read a document instead of reading this. Takes a series of iterables and return 1. It groups all of them together and produces a single. That's what chain does. So when we destruct it, right, it will contain this, will contain all kinds of crap. And then when we destruct it, because they combine into one single iterable, so all the empties is gone. Brilliant. Brilliant use of chain. So this is the same as this. I also see a bit mask. Bit masking. Oh, 10 bits, right? Okay. Bit masks n bits to represent the state of subsets. Oh, yes, we have, and 10 values. The value is minus 10 to 10. If the ith bit is 1, means this exists in the subset. So the two-dimensional subset may contain duplicate subsets. Hash the subset, which is fine. Or just subset also be sorted. Yes, yes. That's the same idea as this, but they use bit. I was thinking, yeah, bin mask is just the position, right? Position. N equals land numbers for I in range n. Get ith bit of the mask. If bit equals 1, the subset not append nums I. Oh, wait a minute. I don't think, okay, I don't know what this bit masking is doing. For mask in range, okay, we have all the mask. Okay, I know what the mask is. And for I in range n, get the ith bit of the mask. If the bit is 1, oh, I see. Yes, because the total result is bit masking from 0, all the way to 1 left shift n. Yes, that's all the masks. And we basically iterate through every value. We iterate through every mask. And within each mask, we iterate through every value inside nuns. And to check if in this mask we include this value or not. If we include it, we append it to the subset for this mask. And we do nice. Oh, nice. You can do it iteratively. I did it recursively. Bit masking. Bit masking is a good solution. Wow. Wow. Bit mask. Actually, I want to try the bit mask. Bit mask is very good. The one-liner is. We'll try one-liner. Note the smart use of chain. Chain can, if an empty list is in a chain, it will be combined with other lists. All right, reference. Give a reference. Reference to this. Yeah, bit mask. This is not bit mask. This is the chain. All right. So what we do is we need no. It's not combinations, but we do use product, and then I think we use chain as well. Okay, we don't use default dict, but we use counter. So, right. So what we do is we need a counter. We need a counter of nuns, right? And for kv in counter.items, right? So when we have key and value, right? We have key and value. What do we do with them? We need to expand them, right? So we're gonna say for I in range v plus 1, right? And for I in range v plus 1 is going to be this key times I, right? So key times I is going to be all of them, right? All of them. And this is going to be another this, right? So for kv, for each kv, we'll produce this. For each kv, we'll produce this. So this is a list, and then within the list is another list, right? And then what we want to do is call product on it. The product has to be called by deconstructing, right? So this one is a list of everything. So we're going to destruct this, and then we call it product, right? And after we call it product, we're going to get a bunch of things. And then we say for P in this product, right? And all the product, that's actually the result already, but the product will be like inside a tuple, right? We have lots of lists inside a tuple. And then we need to destruct the product, right? So we need to destruct the product. But once we destruct the product, what we have is just list. And we need to combine the list together, so we need to chain this. Once we chain this, we can return the final thing. All right, let's try solution 4. No, I think the problem is I cannot call. So probably need to do list chain. Yep, but yeah, let's just do list chain. That's fine. So that's the one line solution. It's very nice, very nice. Now solution 5. I don't even know which one I should follow. But I should follow this one. This is the right one, I think. But this is also fine. I think this is also fine. But anyway, this is bit masking. Right? Use a bit mask to identify where each number, where each value, or when, not where, when, which values in nums need to be included for each entry in the final set, final power set. So n equals len nums, right? And rest is going to equal to a set, and nums need to sort, right? And then we say for mask in 1 left shift n times, right? So we actually 1 left shift n gives n plus 1 bit, but we say masking this, that's going to be 0 to 1111, which has n ones, and that's the mask, right? Now, for each mask, for j in range, we have never used I. For I in range n, right? This is just to check every value, right? And then we need to see if this bit, whether it's a good or not. How do we check? So we check that by, so bit, right, equals to 1 left shift I, right, 1 left shift I, and then we AND mask. When we do this, we need to check, so get the ith bit in the mask. We say if bit, right, so if check the ith bit in the mask, whether the ith bit is 1, right, check if. So we say if it is 1, right, then we know that the temp, let me go to this, and we say temp.append, right, append what? Nums I. So we know this value must be included because its mask is 1, right? And after we do all this, rest.add tuple, right? Tuple temp, right? And after we all done, we're going to return this list tp for top and rest. Okay, solution 5. Int object is not iterable because I did not call range. Yeah, this is the last solution. Solution 5. I mean, might as well, right? We're already here, so might as well get all of them. Yeah. And these will be easy to analyze. right? O 2 to the n, 2 to the n times n. If there's a 2 to the n, that's n. Right? That's easy to analyze compared to this. Right? Very complicated. All right. Anyway, that's it for today. It took much longer than I had expected, but we did end up with 5 different solutions. So see you guys tomorrow. Adios.